Hello, we present to your attention a presentation on the topic, hydrodynamics of the flow of an ideal liquid when it flows out of the bottom hole of a parabolic tank. In order to clarify the relationship between the geometry of the tank and the physical content of its emptying process, experimental studies were carried out to determine the expiration time through the bottom holes of vessels pre-filled with water of various geometric shapes with equal overall dimensions: cylinder, cone, paraboloid. The dependence of the time of complete emptying on the shape of the vessel was found. A feature was observed when the liquid flows out of the paraboloid: the uniformity of the level decrease and the deformation of the free surface. To explain such an anomaly of the process of outflow from a vessel of a parabolic shape, a hydrodynamic model is proposed based on the idea of the movement of particles of an ideal liquid through current tubes of various curvature that completely fill the volume of the paraboloid. As part of the experiment, a container was used, which is a cyclone nozzle for a household vacuum cleaner and meets almost all the parameters of the paraboloid of rotation. To clarify the dependence of the emptying time on the geometric shape of the vessel, similar studies were also carried out with conical and cylindrical tanks with the same overall dimensions and diameter of the bottom hole. The results of the experiment are shown in Fig. 1. It should be noted that, starting from the diameter of the bottom hole equal to 6 mm, when emptying the paraboloid, a curvature of the free surface of the liquid, a deflection in the form of a vortex-free funnel was observed. The formation of a funnel can cause the appearance of features of the outflow of liquid from a parabolic tank, a decrease in the level at a constant rate during emptying. Indeed, the formation of a funnel during emptying occurs due to the uneven distribution of the axial component of the acceleration of liquid particles on the free surface, the plot of which is shown in Fig. 2. It is assumed that the current tubes, elementary trickles, the curvature of which decreases from the vessel wall to the axis of symmetry, completely fill the axisymmetric fluid flow when emptying the paraboloid. Fig. 3. A liquid particle, being in a rectilinear current tube, moves with acceleration directed along the axis of the tube, which balances the pressures at opposite points of the cross-section of the elementary trickle. In the places of curvature of the current tube, the particle moves with centripetal acceleration, and the centripetal force acting on it, directed to the center of curvature, leads to the appearance of a pressure gradient on opposite sides of the cross-section of the current tube. To describe the experimental results obtained in the work, which is a continuation of the research, and to explain the features of emptying the paraboloid, a hydrodynamic model is used, which is based on the movement of an inviscid fluid particle along curved current tubes. It is assumed that the curved current tubes, elementary trickles, completely constitute an axisymmetric fluid flow during the emptying of the paraboloid. Fig. 3. To calculate the velocity of the liquid level during the emptying of a vessel of parabolic shape, we use the expression for the velocity when emptying a vessel of an arbitrary surface of rotation. It is known that for vessels of the shape of a paraboloid of rotation, this means that expression 1 is valid for all z and r, including h0 and r0, then, and the time of complete emptying of the parabolic, shaped container is equal to. It should be noted that the obtained formula 3 is quite suitable for calculating the time of experimental outflow of water from the bottom hole of the paraboloid in accordance with Figure 1. The presented research materials allow us to highlight the main results. Experimental studies conducted on emptying pre-filled vessels of various geometric shapes with the same overall dimensions and diameters of bottom holes indicate a connection between the outflow process and the geometric shape of the tank. B. In the process of emptying the paraboloid with small pressures and diameters of the bottom hole greater than 5 mm, a deflection of the free surface in the form of a vortex-free funnel is detected. C. The effect of a uniform decrease in the wall boundary of the free surface of the liquid during the emptying of the container was found. D. The mechanism of uniform reduction of the liquid level in the process of emptying the paraboloid is proposed. E. Formulas are obtained that are suitable for determining the rate of decrease in the liquid level during the outflow process, and describing the shape of the deformed free surface. The elements of the proposed hydrodynamic model can be useful in mastering academic disciplines using an idealized continuum model. Thanks for your attention.